Now we're going to be looking at empirical analysis. This is about the best way to run your code based on memory and the time it takes to run it. In the example that we're given, we're asked to consider the task of computing the range of numbers in an array. The range is the difference between the lowest and highest numbers in the array. An initial solution might use nested loops to examine every pair of elements in the array, computing their difference and remembering the largest difference found. So basically, we would have a temporary value right here for the max value. You would have a for each loop in here, and then we'd have another for each loop inside of here, and then we'd have code in here that would update the max value. So this is a basic version of our code. We can actually write this code, and this returns the range of numbers in the given array. This is actually going to be its own method right here, and we're going to make it public, going to be static, it's going to return int, and we're going to call it range. It's going to take a parameter of an array, type int, and it'll be named numbers. We have brackets like this, and this is the start of our method. So we have to initialize our max value. We're going to have int max diff is equal to 0, and that'll initialize our max difference. Now we talked about having two for each loops. The first one is going to iterate through the i's. The outside one is going to iterate through the i's because these loops are going to be encased inside of each other. So the outside loop is going to be int I is equal to 0, and then we're going to have I less than numbers dot length, and then I plus plus. So this one really isn't comparing anything. This for loop is just running through the entire array. If, for example, we have these numbers in our array like this, it would be basically going over each one every time the loop iterates. So to do that, we need to compare our first value to every single value and then change it to the max if it is greater or less than. So we're going to have another for loop inside of here. We're going to have a for int, and this is not a for each loop. It's just it's a for loop, not for each. It's for j is equal to 0, and we're going to have as long as j is less than numbers dot length, and then we're going to increment j every time we run this loop. These are our two loops. So now we're going to find our difference. So we're going to make a new value, int diff, and we're going to do math.abs, and that returns the absolute value of an int value. And just to make sure we have no negative numbers, and we're going to have numbers, and we are going to do if j minus numbers I. So we have j minus the value, or we have the value at index j minus the value at index I, and then the max diff we are going to update here, and we're going to do math.max. What this is doing, it returns the greater of the two int values that are passed in. If we do this, we are just going to have math diff, and we're going to have our colon right here. And then at the very end, after we break out of our loops, we're just going to return max diff. Now we can run through this and look at all of this code individually. So we are writing a public static method that's going to return type int. Its name is range, and we're taking the parameter of an array type int that's called numbers. And for example, we just wrote numbers that would be passed into our method through this array. We have to have a value here that stores the max difference. And then what this is basically doing, it's going to help determine what value is bigger or smaller. So this is just declaring it, setting it to 0, because we're going to do more with it later. Now in our first for loop, we are going to get we'll just say 0th index for now, or we'll say ith. index. So we need to compare every jth index to the ith index. To do this, we make a new variable, type int. We're calling it diff, and we're saying that equal to math.abs. And the reason why it's math.abs is because we need the absolute value. We don't want a negative to be returned in case j is smaller than the value stored at I. What's happening here is we're going to compare the jth index to every ith index, and our first index, both of them, is 1, right? So it's just going to be 0. And then we're going to take the difference of that, math diff is equal to math.max. Math.max, it determines which of these two values passed in is greater. And from here, we're getting 0 as our numbers. And our int max diff is 0. And comparing these two, it's just going to return 0. So our current max diff is 0. And then we're going to keep going. Our current max diff is 0. Now, we are not done with this inner loop because it's not less than numbers.length. Our numbers.length is 9 values. So our numbers.length is 9 values. This is going to run 8 times since it's 1 less than numbers.length. And what it's doing is it's going to compare every value to the first value. So the second value numbers is 5, right? Because if we go through this loop again, j is going to equal 1. And if j equals 1, then the index at 1 is 5. 5 minus 0, that means int diff is going to equal 5. Now we're going to see the difference between math.max, max diff, and diff. Our current diff is 5. Our last max diff was 0. So max diff is going to store 5 now. And we're going to keep going through every single one. We'll do one more. So if our j is now at our second index, that means we're going to have the value 3. We're having 3 here minus 1 here, right? Because I is still 0 because we haven't broken out of this inner loop yet. I is still 0, so it's going to be 3 minus 1. And our last max diff was 5 because 5 was our previous greatest value. So now we have to compare 5 and 3. And since 5 is greater, max diff is still going to store 5. And this is going to keep going until we reach the end of this list. Then we're going to break out and go into this outer for loop again, and we're just going to have the value 2 as our I, and we're going to do the whole thing all over again. So this is a pretty lengthy program. It's gonna take a while to run fully and then execute. Since it has 2 nested for loops, we can say this is roughly n squared statements. For what we have here, if we pass in these values, it's not really a big deal, but if we have an array with thousands of integers, it would take a long time to fully go through this method, and that is not something we want. We want to figure out how to speed up our code as much as we can.